Let's continue our discussion on the normal distribution. We've seen some interesting facts about the normal distribution, such as the tails, its symmetry, unboundedness, location, and shape being defined by the mean and the standard deviation. But there are a couple of other interesting points about the normal distribution. And first, it's the 68, 95, 99 rule. And what this basically says is that each standard deviation provides a percentage of the data that can be found between plus or minus n standard deviations from the mean. So we have a normal distribution curve here on the right. The solid red is represented by one standard deviation. And remember, those standard deviations are similar to those z-scores. They actually are the same. 1 and -1. So 68% of the data falls between -1 and 1 standard deviation. So that means if you know the standard deviation of a set of data and you know its mean, so let's say the mean is 88 and a standard deviation of 2, that means that one standard deviation on either side is 86 to 90. And you can be sure that about 68% of the data will fall between that 86 and 90. So these rules can therefore just be applied a little further to 68% of the data falls within plus or minus 1 standard deviation, 95% of the data falls within 2 standard deviations, and 99% of the data falls within 3 standard deviations. And we also have a concept of the standard normal probability distribution. The curve to the right here is a normal distribution. It has that nice bell shape. It will go on infinitely in both directions. But a standard normal probability distribution is just a special type of normal probability. It has a mean of 0 and a standard deviation of 1. And this is what we call the standard normal distribution. What makes this special is that the numbers on the bottom correspond to the z-scores. Recall that when calculating z-scores, that a number x that equals the mean would make the z-score 0. Thus, the z-scores in this case are the numbers for the standard normal distribution curve. We also spoke earlier in previous module about the area under the curve. And we can do that and we can compute the area for any given z-score. So here we have a normal distribution and we have this pink shaded region here to the left. The line is set at -1 for the z-score of -1. So we would like to know the area to the left of -1 all the way out to infinity. So Excel provides a very handy function to do this called norm.s.dist. So all of these functions that give us the area will always go to the left. They don't go to the right, but we can compute it, and we'll show you that shortly. So by doing norm.s.dist, giving it a z-score and saying true, that true is for the cumulative distribution to the left. So here, given a z-score of -1, we can compute the area in Excel by saying norm.s.dist, -1, comma true, and the value returned is 0.1587, meaning that the area of this shaded region from -1 all the way to the left will be 0.1587. So as we said, since the function covers the area to the left, but it doesn't do the right, we can calculate that easily. We'll use the exact same example. We calculated that the norm.s.dist, -1 true, was 0.1587. If we do 1 minus that, we'll get everything to the right. Remember, all the probabilities have to add up to 1. So if we take 1, we take our complement of the 0.1587, we will end up with 0.8413. So this gives us the area to the right. We can use that same principle to determine the area of the curve between two values, such as -1.5 and 1.5, denoted by this green region. But we'll have to do 2 calculations. First, we're going to do norm.s.dist of 1.5. So that's this area here to the right. And that would give us everything to the left. All the area, the green shaded and then the white area all the way to the left. That value is going to be 0.933. Then we'll compute the area to the left for the smaller number. So we're going to do norm.s.dist of minus 1.5. So that's this line right here, and it's going to compute its area to the left as well, which is the white area. If we subtract the first number from the second number, 0.933 minus 0.067, we end up with 0.867. And so therefore, that's our green shaded region. And that is the probability of negative 1.5 less than or equal to x less than or equal to 1.5 is 0.867. Let's take a few examples, but we're just going to do the notation. We're not going to do the graph. So if we want to find the probability of a z-score less than 0.5, we will have probability of x less than or equal to 0.5. This is our mathematical notation. In Excel, it will be norm.s.dist 0.5, comma true. The value is going to be 0.691. If we're looking for a probability of a z-score less than 1.75, we'll basically do the same thing. Norm.s.dist 1.75, comma true, which will give us 0.960. If we want a probability of a z-score greater than 1.2, or greater than or equal to 1.2, we will do 1 minus norm.s.dist 1.2. Remember, the norm.s.dist 1.2, true, would give us everything to the left. So if we want everything to the right of that, we would do 1 minus. And if we want a probability of a z-score between negative 0.85 and 0.56, we will just subtract the larger one, which is the 0.56, minus the negative 0.85, and we will end up with 0.515. Now, if we wanted a probability of a z-score between negative 1 and positive 1, now these are, remember, the z-score is negative 1 and positive 1 means a standard deviation of 1. We would do the same thing. Norm.s.dist, negative 1, true. Norm.s.dist 1, true. Norm.s.dist, negative 1, true, would give us 0.683. Recall that when we spoke earlier in the module, we had that one standard deviation around the mean is approximately 68% of the data, and that is exactly what this rule shows. Now, those were the standard normal distributions, but it's not always required to use that. If we have a set of data with test scores or income or revenue, we might want to use that. But once we have a mean and a standard deviation, we can do pretty much the same thing. The only difference is in Excel, we're not going to use norm.s.dist, we're going to use norm.dist. So consider we have a data set with an average revenue of $100 and a standard deviation of 8. Using the Excel function norm.dist, we will put in a number for x, we will put in the value for the mean and standard deviation, and then calculate, and then put true, and then it will calculate what the number is going to be. In this case, we're going to get what would look like the green shaded region. So the area to the left of the curve that can be obtained, what is the probability that an order will be less than $95? So we will plug in norm.dist 95, 100 is our mean, 8 is our standard deviation, and then true. That will give us the cumulative distribution to the left, which will return a value of 0.266 or 26.6%. Similarly, the area between 2 points can be obtained. Using the same Excel function and subtracting the area of the lower value from the high value, we can figure out what the probability is between those 2 points. We will compute, let's say, for example, if the average revenue again is 100, standard deviation is 8, the probability of a sale between 96 and 104. So we'll first compute the 104, norm.dist 104, 100, 8, and true. We will compute the smaller area, which is the leftmost value, which is norm.dist 96, 100, 8, and true. We subtract the larger from the smaller, and we will get 0.382 or 38.2%. And this basically means that the probability of sale between $96 and $104 is about 38%. Looking again at some examples like we did before without the graph, again, assuming the same mean and standard deviation, what is the probability of sales being less than $92? Probability of x less than or equal to 92, we have norm.dist 92, 100, 8, and true is 0.159. Sales less than 106, we'll use the same formula, but we'll plug in 106 for x there, and we'll get 0.773. And again, we'll do the same thing for greater than 102. We'll do 1 minus the norm.dist 102, 100, 8, and true, and that'll give us 0.401. For sales between 97 and 103, we will take the 103 value and subtract the 97, norm.dist 103, norm.dist 97, and we will get 0.292. And finally, sales between 84 and 116. Similarly, we do the norm.dist 116 and then subtract the norm.dist 84, and we end up with 0.955. The last line is equivalent to 2 standard deviations, because remember, 1 standard deviation is 8, 2 standard deviations is 16. That's how we get 84 and 116. And by rule, we said that 2 standard deviations, 95% of the data would fall between, and as you can see here, it's slightly larger than 95%. Now, what if we want to go the reverse way? We can invert this process and identify the value at which a certain area under the curve is given. So for example, the value at which 38% of the values fall below. Using the standard normal probability distribution, we have norm.s.inv and probability. And so therefore, given a probability of 38%, the corresponding z-score is given by norm.s.inv 0.38. And the value returned is negative 0.305. That means that the z-score at which 38% of the data falls below is negative 0.305. And that is what you can see here by this vertical line, and the area to the left is 38%. Notice that the true is not needed because it is assumed that it's going to be a cumulative probability, because the probability that you're giving is going to be cumulative, the 38% to the left. We could do the same thing without being at a standard normal probability distribution. What if, for example, we want to find the value at which 30% of sales fall below? Using norm.inv, the value given a probability can be obtained. So given a probability of 30%, the corresponding sales value is provided in Excel, given norm.inv 0.30, 100, 8. So the value returned is $95.80. That is, the sales at which 30% of the data falls below is $95.80.